So if you can hear me over the air conditioning, we've got to Friday and we have got a Rotel 240 here. I can't remember whether this gentleman's a trade customer or not. He sends sets in. Please find enclosed my Rotel 240, which was my first rig back in '83 and has been in storage for many years. I powered it up and it seems to have a few issues. Flickering display, not sure what's happening with the mic, which is included. Well, we'll do the mic much later. We'll service a set on a standard replacement mic and then we know where we are. Not that we service mics, but it looks like we are doing these days. He's also sending 2 porter packs which have arrived, and they are, this is job sequence 4 for this week. We lost out because we had a day nearly without electricity, so perhaps Sunday I might do job sequence 5. Then they'll just be reallocated job numbers for next week, is how it goes. I want to do a Harvard base station tomorrow of my own, so we haven't done a Harvard base station before, and they're well worth doing. So let's see what screwdriver we need to get into his set. You don't get the big speaker like you do on the Binatone 5-star. So it looks in nice condition, unlike yesterday's. What was yesterday's? It was a Cybernet 134. Oh, Harrier CBX, which the customer had asked for a recap whether it needed it or not. But in this instance, I can't see, that hasn't moved at all. None of the ones which have got vents on them, I can't see any problem at all. So, you know, it looks excellent. Most of the capacitors in these are Sanyo, and they tend to still be alright 38 years later. I didn't see a power lead with this, but it might be hidden. So I don't know amongst the tat on this bench. I don't know. Oh, if we've got one. Oh, look, amongst the tat on the bench, we have got one. Wonderful. People are quite right not to send accessories in because chances of getting them back are rather slim. We don't open parcels until we're ready to do them, otherwise content can go astray. So the power supply is on. We'll set that to 13.8. We'll put our standard replacement mic in. Switch on. We'll have set that's lit up. That looks like a dirty selector switch to me. I hope nobody's been having fags in front of this radio. Trouble is, how do you get into it, you know, without destroying it? So what we're going to have to do is unsolder this subboard and see whether we can get any service hole in there. Worst case scenario is we have to drill holes into the switch, and I don't like that. So I'll get a piece of paper. Here's a great piece of paper, the one that came with the job, the letter. I don't have to put a title on it there, save my dodgy handwriting. So we'll switch picture in picture on, and we're into the test set, and we'll start off by making sure the radio's on channel 20, tone high, normal, off, normal, CB, delta 2 into 0, RF gain to full, mic gain to full. There we go. And we'll plug in, because it's rather handy if we do, the test instruments into the aerial socket, and whichever this goes into. Okay, so we're on channel 20. We'll key up. And it's doing TX 2.7 watts. And now we'll look at deviation. Wallow. That's not far out at all. Now we'll look at frequency. So it should be 27,79125. It's dropped as they do slightly. It's still in spec, it's neither here nor there. New sets come out which aren't adjustable worse than that. Mind you, new sets come out worse than that anyway. So we'll do that here and now because it can happen. Somebody mentioned they got a trimmer capacitor which wasn't doing anything, and what can happen if I use this tool, it looks like it fits, and it does in this case. I'll just see if we can adjust it correctly with this. This is the one supplied by RS. I think it's trim tool number 2. I'm going to leave it very slightly high so it's got room to drop. So there we are. So it's 128, and it should be 27,79125. So we tick that off, we're done. So it can feel like it's in there and it's turning, and in actual fact it isn't, but also the metal adjuster thing can come away from the innards. They're 20 picofarads, and you can get replacements off eBay. So let's look at what receive's doing. We'll just set the signal generator to be where we want it. There we go. So if we go over to the Cybernet meter, we can hear the signal generator at 0.0 microvolt. And that's about 12 dB. Between scales, I'm always between scales. It's 0.28. It's 0.28. It's very, very good, and I doubt we'll get anything better than that. I think we surpassed ourselves with 0.23 yesterday after capacitor change. I think some of those capacitors can make the IF a bit less noisy. Okay, we need to start with in fact we don't need picture in picture on at all, so we'll cancel it and probably forget to put it back on. I'm also looking at the time, it's heading towards lunchtime. On these radios we're taking the negative lead to the power supply because it's a floating chassis, and we need to locate, we need to change glasses first. Need to select channel 40. Resistor 4. I mean, how did they check that at the factory? They've still got the wax on it. They must do it from the other side. So we should have 4 volts on receive, and of course we have. We can just bring it down that fraction. We've got it to 4, you know, incredible. So on transmit, we should also have 4. So it's the red trimmer capacitor, TC1. These are really fine adjustments, and even with the ceramic tool, its mere presence affects it. Probably won't get it back as well as it was. I have 4.03 back to receive, 4 dead. So now we'll move to channel 1, and we should have between 1.8 and 2.3 or something like that. 2.5. I could look at the manual, but I looked at it yesterday, and that's receive. We've got 2.14, and on transmit we've got 2.22. So I've gone through the motions of doing the VCO. It didn't need doing, but I've done it anyway. Nothing worse than sending a setback, and then 3 days later they say it doesn't work above channel 37 until the car's warmed up or something like that. So now we're going to go through the transmitter. Now this is where we have a problem. Now I've already got more power. Don't know why that is, but we have. So we'll go through these. I'll put the picture in picture back on. So we're on the 3 watt scale. So we're just about at full scale deflection. So that's that one. Yep, that's correct. As these left the factory, they're set for 3.8 watts. This is now doing 3. So we'll go over to the 30 watt scale. Why won't this fit? It did yesterday, doesn't today. I'm going to use a wrong tool. And if I break anything, I have to pay for a new one. So we've got maximum on L4. So 3.6 watts. Wrong tool again. Have to be so careful with the wrong tool. One slip and it's broken. It's not going to have it with that. You know, why are they tight on this one? I think that's far too... I might be able to do it. Sometimes the next size up can just about fit. And we were at 4 watts, but you know, I wanted to do this properly. Okay, so we've got about 4.2 there. So I'm going to have the manual because I can't remember which is clockwise and which is anti-clockwise. You're supposed to be setting this one clockwise, is it? Clockwise for 4.4 watts, which the radio doesn't do. So we're going to do clockwise till it starts making a difference, which is there, which is 4.1 watts, and then anti-clockwise on this till we get to 4. What we need to do is to balance it between the 40 channels. So the idea now is to check channel 1 and 40 to make sure we're pretty close. So there's channel 1, spot on the 4, and there's the channel 40, which is spot on the 4. Don't often get a result like that. But I mean, sometimes even these sets won't quite achieve 4, and this one did manage 4.1. But there you go. It's just the way it is. Tolerance between components and all that. And I can't see it's being fiddled with, so we can now say 4 watts. Wonder if it's ever done that. So we'll look at deviation. I want this mic gain 1 to central position, or whatever it is. I mean, that looks spot on. Wallow. Just wants that fraction more. Wallow. That's it. So that's his deviation now. 2.2 to 2.5. Wallow. 1, 2. Wallow. Actually, I can still give it some more. Its peak is 2.3 and a bit. Wallow. 1, 2, 1, 2. It's one of those, this. Wallow. That's it. A lot of adjustment for little gain, you know. So now we're going to look at low power. So if I can find a switch, it's the one that says -10 dog biscuits on it. We'll switch to low power. Often that control is dirty, and in this instance it's not working at all. So we'll start by applying some service oil switch cleaner to that. We'll work it in, see whether we get anything now. We do, and that's 400 milliwatts. Excellent. So that's restored that function. So now we'll go back to high power without catching the volume control, and we'll make sure that the meter on the radio reads something like 4. So key it up, it reads 5. Oh, I've gone and adjusted the deviation. I'm glad I'm not a builder. I'd tread in all the newly laid cement, wouldn't I? So back to deviation. Wallow. That's it. So that is transmit done. And now we'll move on to receive, and we'll start by putting the oscilloscope on. With an S9 signal. And I say every time, all this is connected across the extension speaker. It's a very cheap oscilloscope, £110 brand new last year. We have 2 of them. We don't do diagnostics. You don't need a 27 meg scope. You're not looking at that. So S9 is 100 microvolts in the UK for a CB radio, and the detector, which I can never remember, is the one down there. I'll tell you what, it's spot on. Didn't need adjusting. So now we'll set the Cybernet meter, so we've got about 4 dB on the Cybernet meter, and we can start tuning the early stages. I'm not expecting to achieve anything because it's already excellent. Tell you what though, we made a change there. And then we'll put a bigger signal on just to do these IF ones. Can't see that one. I'll put an even bigger signal on. Seems to be there. Just check with the small signal. Yeah, seems to be there. Now we'll recheck where we were. So there's 12 dB. And we're now at 0.26. Virtually no difference, but I've got 0.26. So now we'll go back to that S9 signal and we'll look at where the S meter thinks it is. And the S meter thinks it's not quite S9. So we'll do that. He'll have his signals booming through now. Good grief, we had it booming through, didn't we? We were trying to do the on-the-air test yesterday with all the interference because of a bit of a lift on. You know, I know a lot of people will be really thrilled about that, but not when you're trying to talk down the road. So, oh yeah, that leaves us with squelch. So I'm going to turn the squelch to full, and I want the squelch to come in at 100 microvolts on full. So there's 10 dBs, 10 microvolts, 30 microvolts, 100 microvolts. It's exactly where I want it to be. It doesn't need adjusting. If I'd have needed to adjust it, it's the preset just there. So we're now going to test it at the other end of the scale. I'm going to switch the signal generator to standby, and it's parked at 0.3 of a microvolt. We'll turn the squelch down and then set the squelch for threshold. Switch the signal generator back on. It's come straight in. It's coming in at 0.33 of a microvolt. It's dropping off at 0.29 of a microvolt. So that's sensitive, that's fine. You know, there's some sets where you set the squelch to threshold and the radio comes in about 8 microvolts, and these are the sets where they wouldn't trigger around the scratchy corner. So we've actually done the tune-up. The radio is spot on. It really needs to come up on power, and I think that was his snag there. What we're now going to do is switch the soldering on and look at the time. And we've got -2 minutes. So we'll pause the video and have lunch. So what I've done now is to unsolder the channel selector switch. Get rid of that. Hopefully this will now lift off. Now I didn't say I could put it back together, did I? Oh, well, we've snapped a wire off. Anyone see where that yellow wire went? So how do we get into this? Yeah, it might just be possible to put a tool in there and not break it, just to part it enough to get switch cleaner in. That's it. But the good news is that flickering, of course, is only on the display. It's not actually the channel selector that's doing it. Of course, the only way to get another channel switch is off another set. And that's not ideal, because they're all 38, 39 years old. Now we've got to try not to break any of the tracks when we try and put this back together. Okay, we'll pause the video. I've got a torch underneath there and was able to see the pins. So that's soldered and it's also had the isopropyl alcohol on it. Yeah. Not sure about that yellow wire though. We might have to compare with another set. Now there's quite possible there's a Cybernet 134 in bits somewhere. No, that's not one. But this is. So if we've got a yellow wire which goes down to the front, and the answer is we have, and it goes there. And this is something, a service manual of the type we've got, which is not. Oh, it is the Rotel 240. It doesn't probably tell you where any of the wiring goes there. Well, it's great to have this, but it's not as good as some manuals are. Okay, well, we'll pop that wire back on. Turned the power off as well. It didn't like that, did it? So we now have the display showing and without it flashing. I think it's been to a fag party and got full of nicotine. There we are, done. So the next snag is the factory original mic. So does it work? Doesn't it work? Oh, that one's spraying as well. So we're going to transmit. And it doesn't. So we've got a dirty switch. It gives me that impression anyway. I think we're going to open a mic repair department. Could be a duff lead. Hope not. We haven't got them. And we haven't got them because they're quite expensive and we don't do mic repairs. Right, well, it's not at the mic end. Somebody needs to do a channel dedicated to fixing mics on here, because it can take as long to do this as it does to do the radio. sure it's not wired wrongly, surely. So 2 is common, and we have the common onto 2. Black is receive, and at the moment we have black on 3. And black goes to 3, yes. Transmit on this radio is white, is it? Yeah, white. And at the moment we have white going to 4. And white should go to 4. And then finally our audio will go to 1. So, I mean, that is wired right. So surely the only thing that can be wrong is a duff mic lead, but we'll just check and see if we've got a kind of loose pin here. It's always possible. With a tiny little screwdriver, we'll make sure that these aren't widened. It can be as simple as this. And now I'm not giving up on the hard ones to do, and this is a hard one to do. And this is probably the troublesome one. So we've got it down that edge. We haven't got it down the other edge yet. There we have now. So first edge, second edge, first edge, second edge. Cleaner. I'll switch the radio off and we'll put this in and out about 10 times. Right, switch it on. So once again we'll short out the transmit terminals. So I think we've got a duff wire in the lead. Pity I haven't got any crocodile clip leads on here. We've got a bit of a purple wire. I'll tell you what we'll do. We'll solder the bit of a purple wire in place of the white wire. As well as the white wire, just as a test. Plug that back in, and then we'll hold that onto the white wire, thus jumpering it. Yeah, it works now. Doesn't work. So the white wire is snapped. So where's it snapped? So if I hold the transmit button, it's just there. What a problem. Because I think all we can get are 3-metre leads. I'll see if I can find something. Well, we've got two options. We've got these 6-foot ones, which we bought in to do business radios with. I bought these in the 90s, but they're not. They're longer. You know, they're are they stupidly long? Let's compare. So, standard mic. This kind of cable. Oh, it's not stupidly long, is it? It's a bit longer. I don't think I'll hate it that much. Right, we'll put that on. The only other alternative is to take the head off a new microphone, put his head on the new microphone, we'll charge him $14.50 for a new mic. You know, that was the other alternative. I think these are $3.90. They were $3.95 in 1990s when I bought them, so they're still $3.95. I'm sure there's a law in this country that you can't sell something for more than what it was originally priced at, which is interesting when it comes to antiques. Right, or was it just a temporary law whilst there was super inflation in the 1970s? So I'll get on with this and not enjoy myself putting the microphone plug and head on. So as far as the plug end goes, we've done the plug end. I've put the original clear sleeving back, just about got it in the same position with the clamp, and that's absolutely super. What we've found out is it's the white wire on this which is the screened. Never just put the colours because it was the colours in the other mic. We're using red for transmit, we're using black for receive. We're chopping off these two which are not needed. It's a 6 because it's a 6 conductor cable, and we have to use the white as the audio. So let's look at the mic end because we need to recover that grommet, so we can cut that off there. I'll send him that back and then he can put it on his fire. So that's the original strain relief grommet. So I've pulled a bit more wiring out. I've cut back the sheath so we can sort this out sensibly. So we'll tin that again. So our transmit is red. The way they had it, it was white. So we'll once again tin our red wire. And that just leaves us now with audio. So the mic audio, as it was red. As on our mic lead, it has to be white. To be honest, they're usually yellow or white, but obviously not on these. That was a good failure. It hadn't cooled when I removed the pressure. Good. Now to put all this back together. Goes in there. Then the cord grips in this labyrinth. With the grommet there. And push to torque bar goes back in there. And then we find out whether we've lost all the screws. And what can I charge him? I mean, I don't think the job's worth above £3, so I'm going to charge him £3 plus the mic lead. But, it takes half an hour to do, so it's not earning much, is it? Especially by the time you've found all the parts for it. So he's getting charged £3.95 for the mic lead, because that's what we had them at in the 1990s. And £3 for doing it. So that is done. Does it work? Switches radio on. It receives. It transmits. Have we got audio? Are we on picture in picture? Wallow, testing 1, 2. What he does, it works great. So that's the end of his little mic dilemma. All that can go wrong now is his speaker not work. And until we do the scratchy corner test, we don't really have any proof of that. We've had some rather nice radios this week, condition wise. So unplug the aerial from the test equipment, and we'll plug in the roof aerial and hope there isn't a racket like there was yesterday. So mic gain, RF gain, normal, delta tune to centre. One Niner Roger.
bit quiet.
He's a little bit quiet. Well, he sounds like he's got a bit of bucket.
Yeah.
19 a Roger. Okay. I tell you what, we'll leave it on standby, waiting for a scratchy corner test with Mr. Chippy later on. So there we have it, a rather nice Rotel RVC240 now with a new mic lead. Probably last did a mic lead in the 1990s as well. And there's his naughty old one with a break somewhere. So thank you for watching.